We want to find the limit as x approaches 0 of 1 over x squared minus 1 over 1 minus cosine. So let's rewrite 1 minus cosine using the double angle identity. So we have 1 minus cosine 2x over 2 is equal to sine squared. And so if I let x equal x over 2, this is going to equal sine squared of x over 2. And the 2's are going to cancel here, so we have 1 minus cosine over 2 equals sine squared x over 2. And so solving for 1 minus cosine, we get 2 sine squared of x over 2. So that's good. That's what's going to replace 1 minus cosine. And so the goal here is to have sine squared of x over 2 over x over 2 squared. If we can replace that somehow with this, but we're going to have to multiply some things so that it is equivalent. So we have sine squared of x over 2 over x squared over 4, which is just the same thing as saying 4 sine squared x over 2 over x squared. Now, we have 2 sine squared x over 2, so I have a 4, so that means I need to multiply the top by 2. And then, actually we'll do it over here. So multiply this by 2. And then we want to get rid of the x squared. So I guess this is all over 1, by the way. So do 2, and then we want to get rid of the x squared. Okay, so this works because if you cancel the x squareds, this becomes a 2, this becomes a 1, and that's exactly what we have here. So let's rewrite it. So we have 2 over, so these are equivalent, so we'll just use this form. Actually, yeah, we'll use this one here. So we have sine squared x over 2 over x over 2 squared, and then don't forget to multiply that by x squared. Put this one by x squared. So in other words, we have 1 over x squared minus 2 over sine of x over 2 over x over 2 squared times x squared. This will go to 1, because essentially you have sine of x over x, that goes to 1, and so if you have sine x over 2 over x over 2, that also goes to 1, and if you square this, that also goes to 1. So now we have limit as x approaches 0, 1 over x squared minus 2 over x squared, which is the same thing as saying negative 1 over x squared, and we know that's going to go to negative infinity. And so that's going to be our limit.